Hello, welcome to AI Plus Unilag Virtual Bootcamp. So I'll be taking class on getting started with machine learning. So let's move to the next slide and know little facts about me. My name is Rahim Nasruddin Adileye. I'm a data scientist centered at Axam Anzad. I'm a Sunday student ambassador for Nigeria. I've won a couple of machine learning hackathons in which I use the various machine learning tools I'll be trying to explain about. Hashtag number 21, the Central Africa platform where data science competes to another, try to solve different African problems. So my focus here will be introduction to machine learning. I'll be taking you through Numpy, Pandas, and what Seaborn and Matplotlib. So we can just see these three things actually follow themselves. So I would call it the best directory, the Numpy, the Pandas, Seaborn, and Matplotlib. When you are trying to work on any machine learning project, you want to embark on any machine learning project, these are the first three important libraries that you must understand and you must know in order for you to work efficiently and very well as a data scientist or machine learning engineer. So it takes a lot more to know all these things. So let me just try to do a brief introduction about the following packages or following tools that we use in Python. You have Numpy. Numpy is a math library for Python. It enables us to do computation efficiently and effectively. It's better than regular Python because of its amazing capabilities. In these articles, I'm just going to introduce you to the basics of what is most required for machine learning and data science. So that's what I'll be trying to talk about also. So Pandas has been one of the most popular. So what is Pandas? It's not Pandas like Panda or stuff like that. So Pandas has been one of the most popular and favorite data science tools used in Python programming for data wrangling and analysis. So we use it for data wrangling, for data cleaning, for trying to do different dimensions to our data and due to our data analysis in order to make more inference of more business analytics of it. So data is unavoidably messy in the real world. Unavoidably messy is that when you're trying to collect the real world data, maybe customer data, the data you want to connect on a particular feed or stuff like that, you can never be 100% sure that this data is already well formatted. So that's where Pandas help. And Pandas is seriously a game changer when it comes to cleaning. Maybe your data is dirty, transforming, trying to transform trying to do some transformation from categorical data, maybe from an object to numbers. So manipulating in order to do some additions and analyzing the data. In simple terms, Pandas helps to clean the mess. So the Seaborn and Matplotlib is a Python library created for enhanced data visualization. It's very timely and relevant tools for data professionals working today precisely because effective data visualization and communication in general is a particular essential case. So you can see from what I've mentioned before, the three little definition about these three packages are what because it's going to be very, very essential because what's the job of a data scientist? We deal with data. If there is no data, there shouldn't be any machine learning. There's no data, there is no statistics. So these are the following packages that we are going to be looking at and try to see what they do and how really helpful would they be when we are trying to go into advanced machine learning classes, maybe when trying to build a regression model, building a classification model and stuff. So I'll start with NumPy first. Sorry. So NumPy. NumPy is a linear algebra library for Python. The reason it's so important for data scientists with Python is almost all the libraries in the data ecosystem and rely on NumPy as one of their main building blocks. So we must know little things about what we call linear algebra in our mathematics and stuff like that. So we know what linear algebra actually means. We have seen so many things. We've seen the matrices, all those kind of stuff. So that's what NumPy is also. NumPy is incredible fast as it's buying these three libraries. So let's just try to move on and go on with our class on NumPy. So installation instructions, since we are going to be using Jupyter Notebook, so I don't think we should have any problem with that. So we just know that if you want to use NumPy, we use import it out as MP. The reason why we use it import as MP, instead of trying to write NumPy, NumPy can be 5 letters over MP, so it's already an import NumPy as MP. So NumPy has many built-in functions and capabilities. We won't cover them all, but instead we focus on some of the important aspect of NumPy: vector, arrays, matrix, and what, and number generation. So let's start discussing by discussing arrays. So what are NumPy arrays? NumPy arrays are the main way we use NumPy throughout the course. NumPy arrays essentially comes in two flavors: vector and what, and matrix. Vector are strictly 1D arrays and matrix are 2D. But you should note the matrix can have only one row and what, and one column. So a matrix can be 10 rows, 5 columns, and stuff like that. So let's try to see what's going to happen. So we should try to take, if you have tried to talk about some little Python data type like a list, NumPy is more similar to a list. But for example, now try to compare a list and a NumPy. You know, in a list, when you are trying to use the addition sign, let's say I have list A, that's 1, 2, 3, and I have list B, 4, 5, 6. Instead of trying to do the addition, what the program is that you should try to calculate 1 and 4 to be 5 and stuff like that. It doesn't do like that. So instead of like concatenate them, it joins them together to be 1, 2, 3, 4, 5, 6. So NumPy does not do. When you do such a thing in NumPy, it knows what you are actually saying. So let's try to move on. So this is my list. My list is created. So we must transform into what, to array to work with it. We can see here now. This one we call list inside a list. This is a list inside a list. So we have list inside a list. So trying to do, when you convert it to array, it turns to what, 3 rows and what, 3 columns. So it's some built-in functions about NumPy. These are the things that comes with what's already packaged with NumPy. They are already installed in NumPy. They are already written in NumPy. So that's what we call the built-in methods. So we have the arrange function. What does the arrange means? So it tells you was np.arrange 0 to 10. So the 0 is the starting point and the 10 is the ending point. Similar to list, when you are trying to do some selection indexing, that the start will be what, inclusive, while the end will be what, exclusive. That's what this guy also does here. So the np.arrange also have what we call the start, the end, and the what, and the step. So the 2 is the step, and we know that the end will be exclusive, will not be included. So that's why you can see 0, 2, 4, 6, 8. So we can try to generate some zeros, arrays of zeros and stuff like that in using our NumPy. So when you say np.zeros 3, you are creating a what? It's a 1D array. So when you want to have like 2D array, that's why you use np.zeros. That was 5 by 5, 5 rows, 5 columns. You can create np.ones. You are creating a 1D array. So you can create np.ones 3 by 3. So you also have what we call what, line space. Line space return evenly spaced number over a specific interval of time. So what the line space does is just like it's trying to return a what about, right? So it's trying to return 3 type of number from 0 to 10. So that's why I gave you 0, 5.0, and what, and 10. So this is telling us here that to generate evenly distributed number from 0 to 10 in 50 was 50 times. So we have the I function we use to create our identity matrix. So you can try to generate some random numbers with NumPy. Also, you can try to generate uniform distribution. So np.random 2. So generate an array of 2, 0.5 to what, to 0.20. So np.rand 5 and 5. That's for 5 rows, 5 columns. And we know that random numbers are meant to change every time we are trying to run it. So those are the little things about random numbers. So np.rand then 2, that's when we are trying to create a normal distribution. So rand and random are different from each other. So create one diagram 5 by 5 also. So what the rand it also does is just like trying to create the random numbers, but what they will be in integer formats. The following are what in floats like decimal 0.5, 0.2, 0.2.29. But when you want to generate maybe you want to generate a number from 1 to 20, maybe you assign that 1 equals to this, 2 equals to this, 3 equals to this, and stuff like that. So np.rand it from 1 to 100. So we know that the one we can generate a random number that is what, 1, but we can never see 100 because the high will be what, exclusive. So 61 rand is equal to generate random number from 1 to 10 in 10 times. So some array built-in functions. The first array is that if you arrange it in what, 25 times. So you know it's going to start from 0 to what, to 24. And second is the NP dot round it, generate a random number from 0 to 50. So 10 times. So that's what the guy does here. So we can try to do some reshape functions. You should know that what they should be conformable. 25, when we want to do some reshape, we can do 25. 25, 5 times 5 is 25, right? Which is good. So those are the one of the things that we try to take in. So we have the max, the mean, argmax, and argmin. So go back to our what, one array. So what is the maximum number here? If we can try, let's say we now have like 1 million arrays. Will I be finding it one by one? No. Just using max, I know I will get the answer for my what? For my maximum number being in my array. So that's 46. Also, I want to identify where is this, if 1 million, where is this, and the highest number is occur. Where did this guy occur? That's why we use argmax. So what is the index of the what? Of the maximum number in our array? So the index is first what? Index 3. So the same as the minimum, same as the what? As the minimum also. So we can try to do shape. So the first shape of the array is what? Is a vector. So we can try to notice the two sets of brackets. So we try to take it to 1 by 25. That's the first row. That's 1, and 25 what? Columns. So we can try to do it that way also. We can try to use 25 rows and what? And 1 columns also. This is what the guys does here. So you can try to do data size. You can try to change data type, change data type into data 32 and stuff like that. So we can perform some operation with Numpy also. So we can perform so many arithmetic operations. So we import our number as NP. So I'm arranging number from 0 to 10. When I had it here, you can see that it's following what element wise, unlike a list that I used to concatenate. So this one also, it does that. We can do addition, multiplication, subtraction, and stuff like that. We don't have much time. Let's try to go. So we have some universal array functions. Instead of trying to write a function for square roots, you can just use the numpy built-in functions for that, built-in method for that. You can use the exponential, the maximum, the minimum, the log error. I can see the array, and we can try to select some little stuffs. I want to select the value what at index 8. Give me 8. I want to select for if I take for a particular list also start from 1 and what end at 5, and the 5 will not be what? Index 5 will not be what? Will not be inclusive. That will be what is going to be exclusive. So those are the two things. These are little things about matrix 6. So trying to have here now, I'm trying to have an array of 3 by 3 matrix. So indexing rows, it starts at rows from the general format here, array 2D rows, comma columns, or array 2D row, comma columns. So we should try to know what's happening here. So when I say array 2D 1, it tells me that I should select the what? The second row. You know, index can't start from 0, but we can't it from 1, right? So from that start from 0, 1, that's why it brings the what? The second row for us. So this one is telling you second row and what? First column. That's what? That's 20. So what this one is telling you was this one is replicate of the what? Of the output of 113. So this one is telling us the what? To select all rows, but shouldn't select the last row because we have 3 rows, 3 columns. And we know that it's going to 0, 1, 2. So the 2 will not be included. And this one will start from what? From 1 to the other part. So this is what this guy does here. So let's try to move on to what? To our pandas. It's very, very essential also. Sorry, so we are moving on to the next section, which is introduction to pandas. In this section, the course will learn how to use pandas for data analysis. You can think of pandas as an extremely powerful version of Excel with a lot more features. In this section of the course, you should go through the notebook in this area. So we have introduction to pandas, which is one the series, the data frame, the missing data, they group by the merging, the joining, and the what? Joining concatenation. Merging and joining has been a very old fashion, but normally say you want to join data also. So we have the different operations and the data out input and what and output. So let's start with the series functions. So the first main data type we will learn about for pandas in the series is the series data type. So we have to import pandas as what as MP. A series is very similar to NumPy array. In fact, it is built on what? On the top of NumPy array object. What differentiates the NumPy array from a series is that a series can have axis label, meaning it can be indexed by a label instead of just a number location. It is also need to hold numerical data. It can hold any arbitrary Python objects. So let's explore. We can see in here now, our throw is be copied to what? To complete import number as MP and import pandas as what? As PD. So let's try to run it. So when you want to create a list, you can create a series from a list, either number, floating number, object, and stuff like that. So from a list, I'm just going to use pandas function pd.series. So the argument of data equals to what? My list. So it gives us what the actual index, counting from 0. If you want to write, I will write 1, 2, so count from 0 to 2. So I can also select my index is equals to label. We have a variable called label up here, so which is ABC. That's what the guy is trying to do here. So instead of trying to select the argument, once you know the normal chronological way that these arguments follow themselves, we shouldn't try to waste our time in order to specify those arguments. So those are one of the things. We can try to use a dictionary. Also, a dictionary is when we have a key and an items, right? So we have data in a series. So using an index also, I'm trying to create another series 1 to 3 for the index USA, Germany, USSR, and Japan. So when I call the variable name SCR1, so I can try to have another series SCR2. You can see USA are common in both, Germany are common in both, Italy and USSR are not common, Japan are common. So when we try to do some, when you have USA, Germany, Italy and Japan, that means total number of values that we have, that is, in a set, we try to remove duplicate values. USA are duplicate, Germany are duplicate, USSR are not duplicate, Japan are duplicate also, right? So if you count it, it's going to be 1, 2, 3, 4, 5. So trying to do some little operation with it. Those people that did not find their matching pattern, have a score. So Germany find this matching pattern, Japan find this matching pattern, and USA find this matching pattern. So let's move on to the data frame. What reading has been in data science, because coming out of trying to deal with data wrangling, data analysis, you can't say you have just only a particular column or a particular features. What does it really mean? Do you even need machine learning for that? So moving here now, let's try to talk about data frames now. So what is data frame? NumPy.random.import random. np.random.c. The seed is very, very important. If you want to generate a replicate values from your system for anywhere, setting the seed from 0 1 will generate the same random numbers. But trying to not set it is keep on give us different numbers. So PD data frame generate a rand n. If you remember, rand n is to generate uniform distribution. Rand is for what? No, rand then is generate normal distribution. Rand is to work for uniform distribution. So this here now, the rand then 5 rows and 4 columns. This index, make the index A, B, C, D, E, and make the columns. We have 4 columns and we have 5 rows. So you can try to do some selection and index like we did in list and we did in NumPy also. So I'm just trying to select a particular columns here. So I can select more than 1 columns. That means I'm going to pass list of columns names. So one of the 2 things we should try to take note of. We can use the SQL system instead of trying to use our brackets and our hyphen. So we can use the dots, but it's not really recommended. So we can try to create a new column. So in Excel now, let's say I'm a teacher and I have a particular score. Say the total number of score is maybe I've recorded their tests. It's score 20 and exam is 50. So I can't be, for me, I will just write a particular example here. Okay, the test score plus the exam score give me the total score for that particular point, of course. So that's what this one also does here. So I'm trying to name it a new variable, new. So trying to calculate the what, W and Y. So I can try to drop my columns and rows. So by default is what? If I know axis equals to 1 means what? Axis equals to what? Columns. If I didn't specify, by default is going to be what? It's going to be rows. So if you try to note of something, does it really actually delete what we are trying? No. Why? Because we did not put the in place function equals to true. So let's try to use the in place function here. You can see that has already been deleted. So we can also drop it this way also. I want to drop index E, which is, we name it row E, when the axis equals to what, 0. So I'm dropping that one what, by rows. So we should take note of that. We can try to use the LOC also. So using the LOC also can be very, very helpful for us. So, or select pace of position instead of what, of label. So the LOC is more of what, of becoming what, a rows of a thing. So I can try to use the allocation is 0, 1, 2, 3. So it's really advisable to take note of those things. So you can use conditional selection also. An important feature of Pandas conditions are using bracket notation, very similar to Numpy. So this is my data frame. When it's greater than 0, I want to know the values in my data frame that are greater than 0. That's why we see through the form we see first, they are minus. So minus is not greater than what? It's not greater than 0. So if I really want to know the values, then I'll pass it into what? Into a list. So let's continue. I want to know more. I want to use W as what? Yeah, anytime you see a particular way where W are greater than 0, you should keep it. So this one also, I'm trying to step with W greater than 0 and try to tell me the what? The Y values. The Y values that are present there. I can try to select more than what? More than one columns. That's what when we started passing into what? Into a list. So for two conditions, you can use the what? The or and the and functions. So when you see the one that be like one or, that's the or, and the and is the what? Is the word with the parentheses. So those are the little things we try to take note of. So missing data, you can try anytime you are trying to deal with what old Python functions. You try to take note of what's trying to deal with missing data. So it's very, very essential trying to deal with missing data. So we should try to take note of that as data scientists. So coming here now, I'm having my data frame equals to df. My data frame equals to df. I can use the df.drop any. So using the df.drop any means I should drop the missing values. If you set the argument equals to 0 by default, so it's dropping any was with missing values. So drop only as equals to 1. It should drop any what? This one should not be rows. This one should be drop any columns with what? With missing values. So drop any when the trash equals to 2. You're trying to take note of all those kind of things in order for us to see what we are trying to do. So when we are trying to deal with basic data, there are some places that you feel like, let me drop this, I don't need this. So this is what we call, these are some cases of what? Of messy data. So instead of trying to drop data sometimes, the next thing we can do is for us to what? Is for us to fill the missing values as a data scientist. So sometimes the record you keep might not actually see the way you really want it. So I can try to figure it in. So the group by function is very, very essential. We create a particular data frame now. Company, Google, person, and the sales. So I really want to do some data analysis without even trying to do visualization on a particular thing. So that's what this guys means. So I'm trying to pass a particular object. You can save this object as a new variable. Selecting it as a new variable p by underscore company df.group. I can name it anything. So when I try to find the mean average of such particular things, I try to find the average sales for each company. So average sales for each company, the standard deviation by sales, and the minimum, what are the minimum people. Minimum people actually, the reason why it's going to bring is that for Google, finance and all stuff like that. So they are really essential. So you can try to do some merging, concatenating also with our data frame. So when you want to try to merge anything you are trying to do with SQL, you can also do it but in Pandas data frame. So we are just going to look for the primary key values we should use. So I'm having the data frame. What are the things that are very common? So you can try to do concatenation, trying to join them. This one is trying to join them by rows. You can see that anytime the first line of A to 0, A4, A5, and stuff like that. So for example, when you're trying to join by columns, you try to find to miss some values. So try this when you are trying to merge with a particular key. So this is what merging does. So I'm trying to merge in now and how. I can try to perform some specific operations using pandas. I want to know the number of I want to know the number of unique values I'm having. Instead of the number of unique, remove the duplicate values. So that's why I tell you 3 things are unique. And try to select a new data frame using like conditional selection. I can try to use the apply function also. So I already have a particular function that was times 2. So anytime I'm calling times 2, you know that you want the word times 2 particular column 1. So I'm trying to use the apply functions and stuff and stuff. Power negative removing a column, we use the delete like we can do inside the list also. So those are one of the things we should try to take note of. We have so many things that we can't actually finish like that. I can try to sort my values. I sort by column 2. The 4 is the lowest, then 5, then 6, 6. But it doesn't deal with the column 3 because I specified I should sort by columns too. So df dot is there any missing value? It's 10 years first. So we can try to fill my NaN, df dot fill NaN and stuff like that. So let's say data input and output. We can try to have particular data mostly come from trying to transform into Excel sheet or any type of sheet. So the data input and output, it can be in CSV file. You can try to read our CSV file. You can try to use it to read the Excel file, use HTML file and read SQL or stuff like that. So Pandas is a very essential tool. In subsequently class, I'll be trying to talk about the real machine learning, trying to work with the real world data. We are going to learn more about all those kind of things. So we are going to learn more of those kind of things. So our work now is to move on to to Seaborn functions. So what does Seaborn actually does? We'll be working with a famous data set for this exercise. Later on the machine learning course, we will revisit this data and use it to predict survival rate of passengers. For now, we just focus on the visualization of the data with Seaborn, which is actually nice. So our trail has been completed now. Import Seaborn as NNS, import Matplotlib as PLT and stuff like that. So we can try to select the particular background for our data. So we have our data, we have our standing data already. And try to have a joint plot. The x-axis is the fear and the y-axis was the age, trying to tell us the Pearson correlation among fear and age, 0.096, which is very low. That should be around 9% and the p-value equals 0.01. You can try to have a distance plot. We try to tell what's how distributions the fear actually falls out. So all these pins, KDE, these are the parameters you can pass it to especially you can try to have the RX, the bus plot also. What did our bus plot does just trying to take the class as x-axis and y as age. So it shows us what are the various distributions each age first for each classes. So what actually separates those bus plots, like these are the median values, and when you see that's where they have a little outliers. So we have what we call this one plot also. and we have the cant plot, just like in normal bar charts using cant plots. I can also check our correlation, the heat map functions, how correlated they are. You can see that the 0.9 indicated how strong they are. You can see for diagonal thing, they are already what 1.00, which is normal. So they are just replicative value of themselves. Try to set a phase set weight and see how the distribution works. For a particular age, when we say the sex equals to male, you can see like the higher age is around 30 and the female is around 34. We have more male than female. So these are one or two things about Python for visualization. So we can try to move on to the matplotlib function also. So matplotlib overview lectures. So matplotlib is the grandfather library for this version with Python. It was created by John. I created it to replicate MATLAB, another programming language, plotting capabilities in Python. So if you happen to be familiar with MATLAB, Matplotlib will feel neutral to you. So it's an excellent 2D array graphics. So Matplotlib is also what very, very essential and very, very sweet. So it takes a lot of effort, takes a lot of trainings and trust, takes a lot of practice in order to know what this tool really does exactly and trying to enjoy it much more better. So the installation is already done. So let's just try to check few things about Matplotlib. I'm trying to create a 9 space from what? From 0 to what? 0 to 5, the x and y. So I'm just trying to do the plot here. Plot x against y and red is the color. So I'm trying to name the x label, my axis. I'm trying to name my y label. I'm trying to give it a title, string title here. So I'm trying to create a multiplot on the same canvas. So what this one is the number of rows, the number of columns, and the plotting numbers. So example here, the number of rows is 1. You can see that we just only have 1. We have 2 columns. So the plotting number 1, 4 is equals to red, and the plotting number other is equals to what? Equals to green. So Matplotlib object-oriented method. Now that we have seen the base, let's break it down to more formal introduction to Matplotlib object-oriented application programming interface API. This means we will instantly figure out objects and then call methods or attributes from that word, from that object. So we can do as many things. The main idea is using the more formal object-oriented method to create figures of it and then call methods or attributes of that object. This approach is nicer when dealing with canvas that has multiple plots on it. To begin with a create. So this one we are trying to set our figure size. That's an empty canvas. So you have a set of axes. You have the left, the bottom, the width, and the height. So you can plot on the same axis, plotting x and y, and make it the color blue. So I'm setting my x label, I'm setting my y label, and stuff like that. So Matplotlib is a very, very nice concept when trying to do with data visualization in machine learning. We're trying to do with data analysis. So we should be able to understand little things about Numpy, Pandas, and what a Matplotlib function. So it's a very nice thing for us to take note of what we are trying to talk about. Thank you so much for listening to my lecture. Thank you.